Conductive filament is one of the more unique materials you'll come across when you 3D print, but it's rarely used. I think a large part of that is there's not many designs that actually take advantage of that conductive property. So let's see if we can change that. So my end goal of this project was to be able to take something off a 3D printed plate, directly plug an Arduino in, plug it in the computer, and it's good to go. No wiring, no soldering, no assembly. Besides that, plug the board into the print. And I was able to get to that point with this. So this is kind of a mini keyboard, not entirely practical. You're always going to need more than 4 buttons, but it can be programmed to whatever you want. And the only thing I did after printing it was plug the Arduino in. So this used a 2-pin capacitance sensor. So 2 pins in with the sensor right here. And then on the inside, it has 2 lines that kind of go across. I'll show you that on here. So this software is called Fusion 360. If you're familiar with this and you have a little bit of design experience, then this is a very simple object to recreate. All it is a couple boxes. These little boxes have holes in them for the pin, quite small. The pins I found work really well at just 1 millimeter diameter. And then a little pad. You'll notice that between these 2 pieces, there's a smaller wire going between, and this was to act as a resistor. It ended up working better without that in there, interestingly enough, because as you can tell from looking at this, this was printed in white and black. White for regular PLA, black for conductive PLA. But a lot of it is gray. That's because the conductive filament dyes the nozzle for a while. As soon as it starts swapping between materials, you get this grayish tint to it. And although like the lighter gray won't conduct any electricity, or much at least, some of the darker stuff can still conduct a little bit if the pieces are close together. For this design, the actual shell of it acted as the resistor between those 2 circuits, which I found pretty interesting in that you can play with how much is purging and how big the wipe tower is to see how much conductivity is still left between the 2. But it's a really inconsistent way to do it. And then extending that concept to 2 buttons. With this style, you start to get a little bit of crossover. So when one is pressed, the other one still reads a little bit of a signal. Still functional at 2. And then I got a little bit of ahead of myself and tried to make a 12-button one. So 12 buttons, but only using 13 pins, so shared resistor. Not sure if that was a flaw, but this just would not isolate which one was being pressed. There was a lot of noise and didn't work too well. Made a few attempts. Here is what that one looks internally. So this one, I think at most I had 5 pins working. An example of what the wiring looks like internally and how you can vary it. So the thinner and the less layer lines you use, the lower or the higher the resistance. As you increase the amount of layers, you get less resistance, and also if you make it wider. So in theory, you could design lines of a particular height and width and and length and get a desired resistance. So I'm sure that has some applications. I was going to use it in this project that requires a resistor until I came across some code that works off of 1 pin and is a little bit more reliable for this type of setup. But then after moving on, I decided to go back to something a little bit simpler and a little bit more focused on the end goal of not having any wires attached to it and being able to go directly from the board to the buttons. So this plugs directly in the computer. I'll show some examples of that. And whenever you press either of the buttons, I have it right now set for 1, 2, 3, 4, but it's a simple change in Arduino to be able to set this to any 4 commands. Not anything I'm going to replace my regular keyboard with yet, but if someone comes up with a clever enough design and you're able to plug a single circuit board into it, then maybe one day. Here's a CAD model and kind of what it looks like. If I hide the shell, it's fairly simple. It's just a couple pillars going up to the Arduino, then each of those having their own pathway to their board, and then going up a little bit. A little pillar going in there. I did find that making these completely solid helps a little bit. It is a bit tricky to be able to make these separate. So the spacing between here has to be set at least 1 or 2 layer lines. This really thin section off to the side doesn't actually print. It only prints like the 2 outer edges because this needs a little bit of separation. I'm doing this on a 0.4 millimeter nozzle and was able to get 2 lines between. I think 2 lines is kind of what you need, and if you were to do this on a 0.2 millimeter nozzle or even a 0.1, then you'd be able to get 1 layer of conductive filament going along the side and still be able to get those 2 layers of non-conductive between to get that isolation. But still works with 4. All right, this is just to show the setup. So I got it connected to my computer. Then it goes to a USB-C adapter, and then over to the Arduino and the controller, or to the print. I also have my screen mirrored on here on my iPad, so I can have a nice overhead view and see both of them. So this is the code for it, fairly simple, all on this one page. Alright, so this is one of the downsides of using the 1-pin sensor. This value is different than was before. So this one's maxing out at around 100 and something. Where before I had it at 150. So you get a little bit of drift depending on the moisture in there. Probably how conductive my hand is. And probably a few other factors. So I'm going to change those numbers, right? All right, there we go. Those values seem a little closer to what they need to be. And then I can show you what it also looks like on the graph. So you'll notice that one number, the one I'm pressing, is going to be a little bit higher than the rest, but there isn't that much space. So this is where I probably benefit from a multi-tool head chain or multi-tool head printer, so that that separation is a little bit better. There's a little more insulation. When I press the other one, see orange, that one's barely above the rest. Same with that one. And the green has a little bit more separation. So these 2 outer ones work the best. But if I open up a notepad, and make the text size really big, press digit 1 pops up. Press number 2. This one's a little less sensitive. I had to push down on it kind of hard. And then number 3. 3 also you got to push down hard. And 4. I was getting a little bit better sensitivity before. It could be time of day, or I don't know what, but there's a lot of factors that go into it. But that is keyboard that is 3D printed. Now when I press this, it's like simulating WASD, which is typical buttons you'd use for a move around game. So you can get, probably be a little frustrating having to push it real hard. That can be adjusted with the sensitivity. and it's pretty reliable about only doing the button that you're actually pressing. The first few projects, if I pressed one of them, it was kind of a little bit random which one would actually go off. So having it be so that you had to push down a little bit, I would say it's still an improvement and can be used. But yeah, that is a little demo of it. Yeah, there it is. Up next is a couple other little side projects that involve conductive filament. Actually practical, and I might keep around or keep them in my back pocket, and fully works. So that is this little thing, AA or AAA to AA adapter. How this is set up: conductive on both tips with a little bit of a pathway in between, and then this just slides in, and now you have a AA. One issue with the tool changer is it is gray all between. I'd be a little bit hesitant to leave this in here too long and see if it discharges. It doesn't conduct enough to be able to like heat it up or anything, but it might trickle out a little bit of electricity over the time. That's one of the benefits of actually getting a tool head changer. But this fully works. Only been able to test it on my Oculus controllers, and those you're moving around quite a bit, and it still ended up working. And then going to the more experimental stuff that I was not able to get work, but I think in theory should work. But this is supposed to be an electromagnet. You hook a 9-volt to the inside of it, and then in the center is iron filament, and then a coil of conductive filament along the outside. And for the iron filament, I also use Photopasta's composite iron PLA, and it works pretty good. I'm able to stick magnets to it quite well. But this is a little bit inspired on that, the very simple toy or science experiment you tend to do with kids, where it's, all right, you take a nail, wrap some wires around it, and then connect it to a 12-volt or AA battery, and you can pick up metal shavings. That's almost exactly what this is. An iron core with conductive filament going up and then back down, up and down, up and down, and then back out to here. However, it was either too weak to measure or didn't work. If someone gets it to work, I'd love to see it and see kind of like how you did it. But I'll talk through a few ways I think you might be able to do it and just kind of improve upon this one. So I'll hide the shell. That's PLA. So it's around 50 turns with an iron core. And this was printed solid, and then these are just little pathways to get to the 12-volt. So ways I think this could be improved to get it to work is tighter winding. So using 1 millimeter nozzle in my case wasn't actually that good of an idea because I have a 0.4 millimeter nozzle. So using increments of 0.4, either 0.4 or 0.8, would be one way to get a little bit tighter and more consistent coil to it. Not doing this gradual incline because it's so gradual, it's going to turn into little steps in there. I think possibly doing a flat spiral and then that steps up and then does a flat spiral would help you pack it a little tighter and help you keep the different materials separated. Another way, smaller nozzle I think would help. And then I believe a tighter or smaller core possibly. Wrapping it around something that's closer to a few millimeters instead of what I have in here, which is 15 millimeters. I think in theory this should work, but I don't know. I wasn't able to get it to work. So if you're interested in conductive material and you're looking for something that's a little bit on the experimental side, no immediate use, then I think these are the way to look. And then if you're looking for something with actual practical use for the material, I mean this thing. And then if you're looking for something that has immediate use, or not immediate use, but like just verging on being useful, just needs a way better design and a lot more thought going into it, possibly looking at this. With better code, better design, I mean, you're not limited to keeping the keys flat. You're not even limited to keeping them rigid. There's different ways people use compliant mechanisms to be able to make buttons press, buttons move. So expanding upon this, I think there's a lot of room to improve. But that's all I got. Let me know what you think of conductive material, and if you've gotten any projects that you think are useful, let me know, and thanks for watching.